Okay, hello everyone. The few of you that are here, very proud of you. Maybe you're not aware Vitalik is in some room nearby, or the room is full or something, but that's great. And I won't do it just for the video then. So yeah, I'm going to be talking about rebased rollups. Let me explain that. Let me get there with an example and go over some other solutions that we can find before we get to rebased rollups. And so in this example, we have Alice and Bob. Bob is throwing a party in Bikini Bottom, in the city where SpongeBob lives. And Alice, who's from Wonderland, like some smart contract or app or whatever, Bikini Bottom is another app. So in Wonderland, she got like an NFT at some point where she got like some free passes to attend some events. And SpongeBob accepts the passes, okay? But there's one caveat. Bob's party has limited capacity, right? So Alex has to be quick in making a transaction to get access to the party. And so how can we do this, right? So if we do this on L1, then let me actually go back. So the properties that we want is something that is fast. So Alice and Bob want to communicate fast to do this in a safe way, obviously. Alice doesn't want to think that she can go to the party and then show up. And apparently Bob is not aware that Alice is allowed. In a cheap way, no refunds, right? If Alice spends it, she wants to just do everything at once. If she spends it, it's because there's capacity. Otherwise, she doesn't want to spend her ticket, her pass. In a credibly neutral way, so now today is Bob's party, but tomorrow will be some other party. And it needs to work for NFTs. So the choice of the example is not deliberate, just for one of the solutions that there is. And so yeah, if we do this just on L1, if both apps are in Ethereum, then great, things are saved, no refunds, we have synchronous composability. It's credibly neutral, right? We're using Ethereum where all the apps are, and it works with NFTs. But fast, in this example, it might be fine to wait for 0 confirmations or like 12 seconds to 12 minutes, more or less. But in many examples, it won't be, right? You want much faster finality or want much faster access to the party. And it's definitely not cheap, right? So that's why rollups came out, right? So imagine now Bikini Bottom app and Wonderland app are both in Scroll. So great, now you get pretty much almost all of it with like some caveats on save that it's not the purpose of this presentation. But the problem is this works now because Wonderland and Bikini Bottom are in Scroll, but this is not a given, right? Why Scroll? Why not Optimism, for example? And now we cannot just solve this way. You could say, okay, well, OP and Scroll can still communicate through L1, fine. But we go back to the same problem before when we were using L1. It's not fast, it's not cheap, and actually now you have to deal with partial state transitions. So it might happen that Alice says, oh, I want to spend my ticket to get my pass to get a ticket for Bob's party, and so she kind of like partially spends it, notifies Bob, but then by the time that happens, Bob comes back and says, hey, actually, I don't have capacity anymore, and she needs to get back her pass, which didn't happen before, and she has spent already some money to like lock her pass. Something else OP and Scroll can do to facilitate this, to just say, hey, let's just not wait for L1. I'm just gonna read your state and kind of like believe it and just integrate it on my state. But that changes the safety assumptions of both rollups, because now they need to, basically, if a Scroll starts doing things based on what Scroll sees OP is doing, and then OP breaks, now Scroll might not be able to settle anymore, and it might need to also revert some of the state that it assumed final from Optimism before it was actually final on L1. So you lose the safety bit. And it doesn't even make sense to mention the refund bit because there's no safety. Something else they can do is they can say, hey, let's just choose someone and that we're both going to like give up some of our autonomy just for the benefit of having faster interrupts and like common safety assumptions, that scale well. And an example could be Espresso as a common hub to do interrupts. And we go back to a little bit of what was happening when things were at Scroll only. You get a lot of the benefits, but now you still have the problem of what if, this might work with OP and Scroll, but now you have a third party on an app that is running on Arbitrum, and Arbitrum is not part of Espresso, and now we're back to the same issue, right? Why Espresso and why not some other solution, like OP Superchain or something like that. Now, the third thing, and this is why I put the NFTs, is you can just use some third-party like liquidity provider, and this works when things are fungible, obviously. But in this case, where we have an NFT being used, they cannot just mint it on the destination chain. So and also, I mean, the safe assumptions are kind of different, and of course, you lose credible neutrality again. So apart from losing some things, the most important one of the third-party liquidity providers is it wouldn't work for general state. It only works for fungible tokens. And now it's getting closer to what I want to present. But I mean, big part of this presentation is to like put differences of like the different solutions for this kind of problem. So based rollups is what has been proposed to address some of the issues of credible neutrality for these interrupts between chains. And basically, the idea is to share the sequencer with the L1 proposer, which probably not sure if all of you have realized of this, but it's actually not needed to share the sequencer with the L1 proposer for this particular problem. But definitely, if we all share the sequencer with L1 proposer, it does solve the problem. But the problem is, you still if this is just base rollups without preconfs, right? I'm going to get into that in a minute. But if you're just doing base rollups, then you're following this latency of L1. So you're, again, not really that fast. And it creates some weird incentives in the rollups that they need to be committing quite regularly that also affects how cheap a rollup can be. In order to kind of solve these issues, preconfs have been proposed. And so preconfs is basically, instead of waiting for the regular path to finality that L1 follows, let's just ask the next proposer to kind of like promise, like a pinky promise with some stake that the L1 proposer has that he will propose, include, or like that the execution will result in some result after executing a particular transaction that we're interested in, before he has even proposed the block. And if he doesn't honor that, then he gets slashed some amount. So that now gives you back the low latency requirement, right? Now you're fast. You can be like as fast as the sequencer can provide the preconf, which is basically like in the order of hundreds of milliseconds. We still have some of the issues with dealing with L1 that are definitely more expensive than just dealing with L2s, or like, let's say, non-based rollups. And in terms of safety, you cannot abuse too much these preconfs. Let me explain that with the problem of how economic security scales from where we are all using preconfs, which I think is quite important point of this presentation. Let's explain that in a minute. So, okay, so now here we have Ethereum, and this is an example where nobody's based, right? We have Wonderland that's running on some rollup, its own rollup, and then Bikini Bottom and a different rollup. And then we have Ethereum with like a rotating sequencer, right? Rotating proposers. But in the case of Wonderland and SpongeBob, we have the same sequencer all the time. So if we want an amount of economic security equal to whatever this vault is, imagine this vault is 10 ETH, right? Each of these vaults. And then we have 4 users with 10 ETH, and one of them is a bit more rich. He has like 30 ETH. So if we need 1 ETH, all of them can be proposers, right? They have enough economic security to propose, to sequence. If we put them together, and now there's one proposer proposing for the 3, in order for each of the state partitions for the L1 and for Wonderland and for SpongeBob to get each 10 ETH of economic security, now only the rich one can be a proposer, because we need the economic security to divide by the number of different rollups that this proposer is sequencing. Otherwise, basically, the economic security dilutes over how many rollups the sequencer is sequencing at once. So there's some interest in not sharing the sequencer together all the time, and not being based all the time. So the question is, can we just not be based on demand? And the answer is yes. Yes, I was saying, there's like something called gateways that kind of like tries to solve this problem for L1, which is basically kind of like proposers can sell block space to others to actually propose. So it basically brings more centralization to L1 proposing dynamics. And in a way, based rollups with preconf with gateways kind of like touch what I'm calling rebased rollups from the perspective of being based first, whereas rebased rollups are the perspective of being non-based first. But I'll get back to that in a minute. And this is one. So yeah, so these gateways kind of like bring that problem to like a halt. So eventually you could even have something like just a bunch of gateways that are constantly buying block space, but they can provide the economic security needed for this kind of like situation where there's one proposer proposing for one sequencer, shared sequencer for many rollups. But there's one thing that you lose if you become based, even with gateways, which is out-of-protocol incentives. So gateways, so if a scroll, for example, becomes based, a scroll is running its own sequencer at the moment. So there's a lot of out-of-protocol incentives. Like the company, loses a lot of reputation if the sequencer misbehaves and we're running the sequencer. So it's not just about the stake that gets slashed. It's about the reputation that is lost and how the company like recovers from something like that. Whereas if you're based, this gateway has no out-of-protocol incentives involved in the companies that it's sequencing for. So if it can like do something bad and get slashed some amount, the only thing that it really loses is that slashed amount. It doesn't lose any reputation involved, kind of like out-of-protocol incentives. But anyways, I was saying, so there's like some reasons not to want to be based all the time. And so the question is, can we just not be based all the time? Can we just be based on demand? And this is actually something that was proposed by Scroll first, publicly. And so basically the idea is exactly that. Like whenever a rollup that is not based, that has its own sequencer, that is the one who decides what to do, decides to be based, basically kind of saying, oh, the next block will be built by the L1 proposer. But just this is still a bit underdefined in the sense that if the block time of the rollup is like 1 second, so if there's a block every 1 second, and then you become based for one period, in L1, there is a block every 12 seconds. So how do you deal with that, right, in a way that is safe? But at least you'd solve the problem of economic security only when there's demand, only when it's needed, and the rest of the time, we all go our own way. And so we're now getting closer with these ad hoc-based rollups. Now the problem is bad UX, right? Users are expecting a block every second, and every once in a while, they get a block every 12 seconds. And so this is exactly what I'm trying to solve with rebased rollups. So rebased rollups are basically a very similar idea to, it's kind of like a one step farther than ad hoc-based rollups. It's basically less become based for the next block, but maybe we don't need to wait for the actual proposal. Maybe we can use some heuristics to integrate that state in a way that it should be fine most of the time, and in the bad cases, we need to rebase onto some other block. But there's economic security involved. And so let's go closer at what happens in this case. So in this example, we're seeing like 2 rollups that, for the purpose of the presentation, to make it easier to show, they have a block time of 3 seconds, let's say. So for every block in L1, there's 3 blocks. Oh, it should be 4 seconds. Anyways, there's like 3 to 4 blocks or whatever. There's many more blocks on these rollups. And then there's at some point, there's this transaction that comes in both mempools that requires this shared sequencing. And so both rollups coordinate and say, hey, in our next block, we're just going to notify the L1 proposer for him to build just the next block. And then they get it back immediately, and they start building on it. But let's zoom in into what happens here. So suppose at time t, the next Ethereum slot is going to start. So imagine they have direct communication with this L1 proposer through some RPC endpoint or whatever. And 200 milliseconds before the beginning of the slot, they directly tell the L1 proposer, you're going to build the next block for us. And so at the time of the beginning of the slot, the L1 proposer has enough information to start building on it. He builds it as soon as he can, and which you can imagine is as fast, let's say, more or less, as each of the sequencers when they're running autonomously, non-based. And then as soon as he builds at least the top of the block, assuming he puts this shared sequencing bit at the top of the block, he immediately notifies the sequencers of each of the rollups. And then the sequencers can build the next block on top of it, optimistically, of course. So imagine, I said the block time in this rollup is 3 seconds. So 3 seconds at the beginning of the slot, no UX disruption. Like users get the usual block time of 3 seconds. But that block in the middle, with a bit of a less bright color, has been built actually by the O1 proposer, and it does share sequencing. Now, what happens is, the more you build on this block without it being confirmed, the more you are optimistically building in a way that you might have to rebase, because the O1 proposer might in the end not propose that, and now you have to like revert all that state. But then you realize, as more time passes and I rely more on it, I can also keep tracking what's going on E1. I can see what's being propagated over the network. I can see if there's anything, if the things that I'm expecting to see are happening. And the more I rely on it, also the more confidence I have that this is actually what's going to be part of the final chain. And then 200 milliseconds before the beginning of the next lot, we go back to the same thing. Is there demand for being based? Let's do it again. Is there not? We don't become based. And 3 seconds is an example. It could be even smaller block time. Probably if you start wanting much smaller block time, then you need these to rely on preconfs and the economic security that is slashable on an L1 proposer. But I argue that it's much more fine to rely on very big gateways in this case, because it won't happen like always. It will only happen when there's demand. So it doesn't need to be every slot that you have a massive gateway with a lot of slashable stake, basically promising these preconfs. But for 3 seconds, actually, you might not even need preconfs. You just can track how quickly the block is propagated over the network, like in L1. And here we have this light. And at the bottom, you can see the source for it from the previous DevCon. Yeah, you can see that after 4 seconds, most blocks propagated in the first 4 seconds of a slot with a big degree of confidence will actually make it as part of the, like everybody will see them and they will be part of the L1 chain. And so in this case, we finally have what we want. We have a fast protocol that is safe, that is cheap, or put differently, that people only pay for what they need. So they may have to pay a bit more for synchronous composability when there's demand for it, but if there's not, the rest of the time they're still having the cheap UX and the cheap transactions that they expect. They can achieve synchronous composability. There's no need for refunds. Like if Alice spends her ticket, it's because she gets her pass, it's because she gets a ticket at the party. It's credibly neutral because it's synchronous composability with L1. It works for NFTs. We don't have to rely on any liquidity provider. And you have a UX that is standardized and it doesn't change when you become based or not. And so yeah, that was most of the presentation. As conclusion, so I already explained that Rebased Rollups explore this trade-off between not being based and synchronous composability. This trade-off of non-based rollups being cheap and fast, and synchronous composability allowing some applications in a credibly neutral way that independent rollups don't allow. I believe, so there's this argument that has been lingering in the community that rollups are, like, the Ethereum protocol is like proposing this native, these based rollups, and it's getting harder. Like if in a future where that is happening, non-based rollups lose a bit of their selling strategy, but I argue there will always be a space for faster than Ethereum latency for block time, for example, because Ethereum just has to deal with an amount of decentralization and safety that there will be space to exploit this trade-off, and always provide faster block time at perhaps a bit less safety and at a bit less decentralization, and play with it a bit more when you are exploiting this rollup space. So I think that something like rebased rollups, whatever changes happen on Ethereum will always be there. And yeah, so yeah, I think I already said all of these things. So yeah, now you don't need to choose between fast, cheap, non-based rollups or slow, expensive synchronous composability. You can just have both. So, yeah. If there's any question.
Thank you, Alejandro. And again, in the top right corner, there's a QR code if you want to ask questions. There are some questions already. The first question, what kind of transactions might need this basedness, and how would they be identified? Can users request this?
Yeah, I mean, this is like very, very researchy right now. so the kind of transactions. I mean, I chose the example on purpose, right? Like, so basically, if you saw the slide, like the title said DEX, ideal case, right? I mean, the point is, if you want to exploit an arbitrage opportunity, you need to. Yes, there's the liquidity provider solution. That's why I chose NFTs. But if you put aside, if you want to like your actual ETH to move to somewhere where you can like exchange in some DEX in a different part of the state, then if you are not fast enough, then you might just lose the opportunity, right? And by the time you're gonna do the swap, you're already paying much more, or you're just not exploiting the market. So that's one example, but that one can be that one right now is being solvented by LPs. But in this case, we put an example like this one using NFTs or any kind of app, because with general state you cannot rely on LPs. So I mean, yeah, there's an argument, like, you know, there's some people in the space that say that synchronous composability is not even that needed. But that's the beauty of rebased rollups, right? Like, let's not even worry about that, right? Let's not even try to predict what the demand is going to be like. Let's just like enable both, and based on how the market dynamics change, we go base more or base less, and we don't lose anything really.
Okay. And another question here upvoted: have you explored how this might affect L2 MEV?
So I mean, I've not looked that much into it, to be honest. Again, this is very researchy, but off the top of my head, definitely if you're worried about MEV, you should be more worried. Yeah, I mean, this is kind of like a religion, right? Because you could say on the like non-base space, like there's like one sequencer, so MEV is like much more exploitable there, arguably, in an adversarial scenario. But in the base case, you know, base is gonna like probably gonna come like with like gateways, and you know, gateways also kind of like give the same problem that the like basically a gateway can buy like block space over multiple slots and also theoretically exploit MEV. So I don't think there's like big change happening from rebased rollups in terms of MEV. I might be missing something though.
Gotcha. And then there's a question here, might need some clarification, but I'll try anyway. You mentioned that your initial example doesn't need the L1 sequencer. Why? I didn't understand exactly what you meant by that.
Yeah, it doesn't need the L1 because both like Bikini Bottom exist in a rollup and Wonderland exists in a rollup. So they need Wonderland and Bikini Bottom to share the sequencer, but they don't need to share the sequencer with L1. Like if you need to share the sequencer with L1, it's because you want to synchronously compose with something that lives on L1. But you don't need that in this case. So actually I put the example with Espresso, right? This would be enough. They just communicate through, they both become like rollups that are part of Espresso, and they just like synchronously compose with it. And they don't need to synchronously compose with L1. It's kind of like, but you could also do this on L1 with inclusion precoms, right? Instead of execution precoms. You only need execution precoms really to synchronously compose with L1 state.
Okay. And then a final question, somebody was kind of querying, you're at Scroll currently. Is Scroll working around based rollups?
Yeah, there has been some, I mean, yeah, we're looking at it closely, but we don't have, it's not part of our current roadmap near term to like switch to being based right now.
Gotcha. Okay. Yeah. Thank you for your time. Thanks everyone for attending, and enjoy the upcoming lunch.
Yeah, thank
Let's
you.
give a round of applause.